Hello, everyone. Are you hungry already or starving? Me too, but I will make it even harder a bit during this presentation, but I hope you will forgive me for that. Okay, so today I will have pleasure to talk for some time about tackling cloud complexity, let's say, and more of that, like about the recipes from real-world projects, which I found out, and I encourage people uh, to implement them, and I want to share them. So hopefully I can save you some troubles, maybe, or help you to improve your system. So to answer the question, who am I am not a rock star, even if I wish I would be. So you likely don't know me. So my name is Marek Urbanowicz, and I work as Node.js architect at Inkubli, which is Łódź-based. Don't know what was funny here, but maybe you can share later on. I am co-host of the RTC of Code podcast, which is English language, likely language agnostic in terms of programming podcast, which I run with my colleagues. If you would like to give a like and subscribe, you can quickly scan the QR code, but I will share it also at the end of this presentation. First code I wrote was a MS-DOS based quiz about the Four Tanks Men. Polish people will likely know what I'm talking about, this TV series. And it happened around 95, 96, so some of them will think that I'm kiddo, and other ones will think that I'm crazy old, so it depends on the perspective. I have gained experience across IoT, finance, logistics, social management, and smart city, and that mixture, let's say, helped me to show some examples which I will talk about later on. And on top of the programming, I really like cooking. And why this is important, I will try to explain. So, does anyone recognize what this is? This is lasagna, right? And lasagna is somehow close to the programming, I believe, and a lot of cooking is close to programming. If you look at the lasagna, it's built from the 4 building blocks, let's say. It's bolognese sauce, it's bechamel sauce, it's pasta and cheese, right? A lot of cheese, which is great, right? And if you think about like learning cooking lasagna and getting like better in cooking, you learn lasagna and you think, okay, what's next? What can I do with that, right? And if you think about the building blocks, you can take one, which is bechamel sauce in this case, and make cannelloni. If you will take another building block, you can make spaghetti, right? In theory, they are completely different as our projects in software, right? Because every project is completely unique. It's completely special. Siri woke up for some reason. And every project is special, and everything is really different from each other. But in the end, if we look deeper, we will always find common building blocks, right? To give another example, if you think about these 3 pictures, this is biryani, this is paella, and this is risotto, right? Every dish is super special in their countries because one is Italian, one is Indian, and one is Spanish. But in the end, it's rice with stuff, right? It's basically the same stuff. So even though we think and we tend to believe every project is super unique, in the end, everything or a lot of stuff will be rice with stuff, even though it will end up as completely different thing, right? So, as you can know already, you never know now these days if I'm real or I am like trained ChatGPT robot. So you can have now the opportunity to fine-tune the model which will talk to you. Yeah. So if I could ask you to scan this QR code with your phones quickly, it won't require any app or anything like that. And we will have like quick 3 questions. So I can like tailor the presentation especially for you. Oh, you are already doing stuff. That's cool. Oh, we have a lot of senior people here. That's good. That's good distribution. Yeah, the self-assessment is always the best, right? Because it's like getting us higher and promoted easily. But yeah, that's cool. That's really good. Oh, switched. Oh, keep it running. Keep it running. Yeah, but generally the distribution is amazing. I was somehow expecting this kind of stuff. Okay, that's really good. And we will now go to another one. Do you see there's this question on your phones? The WebSockets maybe got delayed. It's a distributed system, right? So yeah, .NET. I'm working with Node, but I'm crypto fan of .NET. Oh no, no Go lovers. Oh no, there are some. Ah, sorry. Forgive me, Go lovers. Okay, it's really good. The technology's distribution is also pretty good, which is good because we will see any line of code today. So the presentation will be completely language agnostic, let's say. Thank you for the answers, and then let's go to the last one. This is the the word cloud. So if you can try to describe the type of project you work with, like for example IoT, finance, SaaS. Try to give your example so I can like tailor examples which I will be giving to your projects. Oh, finance. Let's go in line with what you said yesterday on the dinner, that there are a lot of banks in Łódź. E-commerce, SaaS, marine. Oh god, such a spread. Device configurator. Is device configurator something like IoT or no? Okay, that's interesting. Okay, cool. That's really cool. So I have now the data to be trained on, and yeah, that's useful. Okay, out of finance, marine. Okay, so let's go back. So today I will go through the sort of case study, but it's not real case study because it's the real project, the one single project which I will go through is just a backbone of the whole idea behind this presentation, and it's like spiced up with many different learnings from other projects, right? So we will be talking about data stream processing. We will not be talking about like stream processing, like video or something, more like data which can be coming to the services like events or messages, this kind of stuff. And basically we will talk about the processing of these events and how we can make it scalable. My university lecturer who passed away unfortunately some time ago used to say that processing is the system where something goes in, something goes out. For Polish-speaking people, it was coś wlata, coś wylata. And I really like this, and it describes the thing really nicely. So if we think about the basic system of processing the messages, the data, it's like, let's start from the system which is going from the top to the bottom, right? So at the top we are getting the data producers, right? What can be the data producer? If we will think about the IoT, it will be for sure the IoT device, right? If we think about the finance, it can be some transactions or any accounting data, let's say. If we think about the analytics, it will be data coming from, I would like to give an example from of Amplitude, let's say. So it will be the data like analyzing the user's behavior on the website. So the business related events, let's say, of or UX related events, right? But it can be a lot of stuff. This data will usually end up on the either queue or the event stream. As we have wide spread of like seniority here, let's just quickly explain the main difference. So the main difference between the queue and the stream is that when the message goes on the queue and is consumed, it disappears from the queue, right? And on the stream, it stays on the stream, and the consumer travels through the stream by the offset, right? So it can go back in time, which is amazing, but it's also difficult in the implementation. Then this data will be somehow processed, right? We will imagine that we will simplify this into one block, but it can be set of microservices or many different systems, right? And at the end, we will have data consumers, right? Data consumers can be either maybe mobile app in case of IoT usually, or some business APIs, or external customers who will like provide the data and expect us to process this data in the good reason, right? And this communication can be both directional, yeah? And but now we will go from the top to the bottom to make it a bit easier. Yeah, and when I was working on this kind of project, the business owner, not the business, the product owner, came to us and he said that the main key requirement for this project is that we have to have ability for infinite scaling. Yeah? That sounds cool. So we said, okay, we'll go with cloud. You will give me money and I will scale it infinitely. Yeah? It is simple, right? Because it's cloud. And he was somehow right, because when I was leaving that project, we had like 500,000 of devices on the production, and it required a lot of scaling. So we started from the very simple system. We had event source, we had event stream, we had message processing, we had message queue, and we had data consumers, right? Why we have event stream now? When I mentioned that we can have a queue, the benefit, and this is somehow a recipe, of having the event stream on the input side is that we can go back in time. So if someone else, obviously it will never be us, screw up something and we deploy wrong code to production, or for any sort of reason we have to go back in the processing and process the data again for, I don't know, from last 24 hours or something, we can do it. And it's fairly easy, yeah? So that's why using the event stream on the input side is really, really beneficial. And another recipe, which comes from their life, which is really often skipped by even really amazing developers, is to measure everything what you can measure, but measure the things which are valuable, right? So as developers, we tend to, if we think about the metrics of the system, we will think obviously about the RAM and CPU. Yeah, it's useful, but for business, if you will say that, okay, we are usually at 80% of CPU, and the business will say, that's good. That's good value for our customers, right? But this is not the case, right? So what we can measure, we will try to give some examples like for business, valuable business metrics, right? If you think about the event source, right? Let's say talk about the IoT, right? What we can measure on the source side, right? the first thing which comes to mind is the connected producers, right? So connected devices to the system, right? The business don't care if the event stream consumes, I don't know, terabytes of data. They will care about cost, but they don't care about technicalities. Yeah, they want to know how many customers are connected, what's the trends, how many devices are coming in every week, let's say. Yeah, so we can be prepared and predict some future, let's say, yeah, with the trends. If we go further, what we can measure about event stream, right? We can measure the data of Kafka, for example, the storage, but this is not really useful, right? It's useful for DevOps for sure to like maybe increase the tier of the service, but it's not useful for business again. So we can measure the delay of the processing, right? How quickly we keep the pace of the data coming in, right? Like say we will measure it and we will be able to tell the business that okay, usually the average delay of the reading is like, I don't know, 20 milliseconds, right? So it's good for the customers because they will not experience any kind of delays, right? And the message processors, this is the example of where the CPU and RAM will be useful because we will know if we need scaling, right? Either vertical, if the platform allows, or horizontal, right? And another on the message queue, it's pretty easy. It's not maybe super business metric, but we have business valuable metrics above. We can measure the number of messages on the queue and if the trends, right? It should never like keep going up, right? It can be going up for a moment, but it should be rather stable, right? Because if it's going up and up, it will mean that we cannot keep the pace and we cannot process, and the consumers are not really consuming the data. And the next thing is the time when we are switching from the technical presentation to live coaching, because we are all going to die, right? And that's the thing which I forgot many times in development, and many other developers keep forgetting about it. When you are developing something for the cloud, you have to remember that your application is going to die, and it will die often. Yeah, it will keep dying, and like a phoenix, it will come up from the ground, and it will be alive again. Why this is important to remember? The graceful shutdowns on the Kubernetes, most of us will deploy to Kubernetes either on cloud or on premises, are really important if you are dealing with serious system, right? So if I would tell you that you are going to die in 90 seconds, I'm not telling that, so don't call and the enforcements. So if I would tell you that you have 90 seconds to die, you would try to, I don't know, call your wife, husband, girlfriend, or whoever, or parents, and say goodbye, right? To keep the things clear when you are gone. This is the same for our applications in the cloud, right? We should die in nice way, right? As the application, obviously. Yeah? So this is another recipe to like remember about dying and think what can happen when you are dying. If you die not cleanly, let's say, yeah? Maybe for sure you could like close the database connection. On this kind of processing, you will first cut the input to give you some time to process what you already consumed from the stream in this case, and then when you are done with the processing, you will say that to the orchestrator that okay, I'm ready to go, yeah, and that's the good thing to always remember. The last thing is more soft thing, but it's really important also in the cloud environment to remember about your system boundaries and talk to other people. Yeah, it's hard, but we have to. Because if you, for example, setting up the RabbitMQ, which was mentioned in the previous talk, you are setting up the RabbitMQ system, and you will your system will end up here, right? With with the publishing, let's say maybe even here, right? And you will be super happy because you are publishing the data for a week, and you are saying to the another team which is consuming the data, hey, you have data from the last week already on the queues, right? So it would be good to start consuming that, yeah? And they will tell you, what kind of data? We didn't set any queues there, yeah? And you will see the happy publishing because the message will go to the exchange, but it will never go to the NQ because it was not your responsibility to set it up, obviously, but you didn't notify the another teams. And the data will be gone in theory, but you can go back in time, and that's why the event stream on the input is valuable. If obviously if the retention period which is on this stream will allow you, yeah, so you can have 7 days, maybe 2 weeks or a month, but it will still give you some backup option if you screwed, yeah. It happens, yeah. We all screw sometimes. Okay, and at some point, based on the CPU metrics, you will see that we are hitting the limits, yeah? In case of Node, if you are hitting the 100% CPU, it's not really, doesn't make sense to scale up because Node will more use just one core efficiently, really. So you will scale up horizontally. Yeah, it's an amazing idea, super simple, more money, and it's working, right? And what happens there, yeah? If we will think about the smart bulb, which we can imagine is here, about me, yeah? And it will keep emitting the data to the cloud, right? And it will emit, okay, I'm turned on, I have some power consumption, and I have some brightness, right? And these messages will go here. And we will have competing consumer situations here. And one message will go to this processor, one message go to this processor, and one message go to this processor, right? And all the messages are about single entity, right? So if they are about different states, it will not be an issue, yeah? But if we turn on, turn off, turn on, turn off, and turn on, it will end up with inconsistent state because there will be a race condition between the processors. And for example, the message which was delivered later will update the state. The earlier will update the state after the message which was delivered later. So we will have like outdated state, and the new state will be gone, right? What can help in this kind of situation? Because we will not always will need like super complex solutions, right? In this case, we can use distributed locking, which is not really hard to get it working. And basically, this will use usually, not always, but usually it will use nowadays the Redis under the hood, which allows getting the locks. What is the lock? The lock is basically functionality which allows us to like being this or this or this processor. We will get the message of the bulb with the ID 1234, and we will say, hey, Redis, I want to process this entity 1234. Can I? And it will say, okay, you have the lock. Yeah. And another messages keep coming from this bulb because it's crazy. And another pods or instances of our application are keep asking, Redis, can I process 1234? No, you can't. Another instance is already doing so. So you can do it, yeah? And it will wait. So this will save us from the inconsistent data state, right? It has drawbacks because if you already probably realized, it will slow down the processing, right? Because if these instances are waiting for lock, they are getting lazy, yeah? They are drinking coffee and waiting for being able to process, right? So, but it can be sufficient solutions in many cases, right? This kind of locking. If you don't have like really big system, locking can be more than enough. To address this issue and remove the need of locking to make it the system processing the data faster, we can use the partitioning, right? some of you, if we had like quite a lot of really senior people here, will say that publishing the data on the event stream should already be partitioned in correct way, so we don't have to partition it again, right? But it's not always the case, especially with some ready tools which you want to use, maybe external tools to not develop and reinvent the wheel. So the data will be not always partitioned in good way, or the partitioning from the tool will not align with your partitioning needs. Because to give the example, if you have IoT again, yeah, if you have many devices which are communicating with each other, you have some automations, right? So do you want to like partition by device ID only or not? What would be the best partition key for the partitioning for the IoT devices in most cases, let's say, right? Sorry? The ID of the device? Not really. Why? Because that if you think about the devices interacting with each other and some automations having to be triggered, the consistency boundary will be the home, let's say, yeah, for in this or the, let's say call it home, right? It can be the place, right? So you want to partitioning in different way, yeah? So you can introduce the partitioner, which will be super simple thing. It can be really thin layer with either no logic or maybe simple logic or a bit more advanced logic, which will spread the data between the partitions. And for example, if all the data, because the consistency boundary of all IoT devices in this room is the room, they will go all to this first, let's say, partition, right? And from the other room, it will go to this partition and another to this partition. You don't have the locking, you have consistent data, and it works, right? And it will be sufficient to some scale, and it will be really enough. What partitioning can also do is to again help you to have like Houston, we have a problem button. What can be this kind of button? Yeah, the data. Let's say you have a lot of data coming to your system, and not all the data is critical to the system, right? It's not always about, we have a lot of finance people here, but it's not always like critical transaction data or so, yeah? If we think about the IoT, maybe the temperature, it's not super critical in the room, but the state of the device, or is it turned on or off, it's rather critical, right? So in this case, you can partition a bit further, even though all the data will be consumed by the consumers on the and the process on the single partition. You can split the partition into two parts for the critical data and for the non-critical data. Why it helps? Because if something goes wrong, and for example, in my life, I've seen many times when using the cloud IoT solution, let's say, to not call it directly, we had like complete outage, right? So half million of devices are offline. Yeah. What will happen when they connect? They will kill you with the amount of the data, right? And some stuff which is usually working will not handle this amount of data. In this case, if you go into the troubles, because maybe the system will handle because you give enough money and you overscale on the daily basis. But in this case, in case of the issue, you can purge the queues of the non-critical data and consume only the critical data, and then keep up with the non-critical data later on when all devices are connected and you are, let's say, after the bad times later on. But later on, the partitioner can become the single point of either failure or it can become a bottleneck. But the partitioner, if you think about it, it's super stateless thing. It just takes the data, figure out the partition, it publishes. So you can scale it infinitely, and you can even distribute it over the regions or availability zones, and it will work. So this is not really a super issue to be really worried about. And this kind of setup will work until some scale, right? Every event stream or every queuing system will have some limits, right? So even though it will work and it will handle, let's say, 100,000 of IoT devices, it depends on the size of the devices, but it's not the subject here. But it will go to some scale. And at some point, you will see the 100% CPU on everything, or you will see the limits on the source. Maybe the cloud solution for IoT will not allow you to send any more messages through the highest tier of the solution, and you will message the support, and they will tell you you have to just issue the new service, right? And that's it. But you say, but come on, I don't have the ability to like process another source in an easy way, right? So you first see, okay, if we deploy another setup like this and another deployment set, then not to mix it up with a deployment set from Kubernetes, it will, in theory, it should work, yeah? But the first issue we see, if we think about the event sources going to the two event streams, and you have to like somehow spread them, is to how to make it happen, right? If it's internal producers, let's say, I don't know, you are consuming the data from financial transactions or something, you can, in theory, ask DevOps to like hard code, maybe not hard code, but provide us configuration, right, to the producers, and it will work. It can work in some situations, but what if it's IoT? If you have hard-coded domain on your devices, which are already on the factory, and you have thousands of devices in the boxes, and you can't change anything about the software, right? You can introduce the producer router. And this is super simple. It can be super simple solution, because if you think that you have amazing domain, let's say connect.io, encoded in the device, saved on the devices, and they will try to connect to this domain, yeah, to get the connection string, or just directly connect to the event stream, right? If you just maybe want to, for legal reasons, you want to do the geographical split of the traffic, right? For example, in my experience, we had like the system. I was not directly working, but I was like helping a bit. It was a system, the financial system, when the transactions from the Indian bank, Indian country, could be only processed in India, right? So the whole system had to be contained inside India, right? So you could just use, for example, AWS Route 53 and do the routing that based on the location, it will resolve the domain connect.io to the given event stream address, and let the customers connect to this deployment set there. Yeah, and from the all other world or from the Europe, it will go to this one and whatever you want to do. But you can do something more sophisticated, because you may need different like split of the traffic, right? If you have, for example, maybe some rules about the customers, maybe they are paying customers, they are free customers, anything what can come to your mind, right? And so you can start from really thin solution, because it can be enough, or you can go really sophisticated solution and to fulfill your business needs, right? And then with this kind of setup, you can go farther. You can have, for example, like one deployment set in subscription 1 in region A, in another one in subscription 2 region A, subscription 3, region B, and cloud subscription 4, region C, right? You can scale infinitely and spin up another deployment set as you need, right? And it will all just rely on the producer router. Again, it's single point of failure in theory, but again, you can do the deployment is pretty easy, so you can make it resilient, right? Multi-cloud deployment, easy with that, right? I don't know that's your experience, but nowadays I can recall many cases already where customers are coming to us and telling that they love Azure, but they will never use AWS, or they love AWS and they will not use Azure. Yeah. So what you can do when you are in this kind of situation, and your whole software is deployed on AWS, for example, and you have customer with $10 million in the bag, and they are telling you, we want to use your software, but you have to deploy somewhere else, right? But you have everything in place, right? You will just introduce the producer router or let's call it input router, and redirect them to another deployment set, which you will set up, because for 10 million bucks you can do a bit for them specially, yeah? Okay, but I kept talking about the going from the top to the bottom, right? So we were consuming and publishing. That's pretty easy with the producer router, and it works. But what if we have the consumers on the other side, and the direction of the communication changes, right? Because it's not going from the top to the bottom, but it's going also from the bottom to the top. Yeah, they are sending requests, and they want to consume the REST APIs. We can again do almost the same thing which we've done above, and introduce the router, but on the consumer side, right? So when the consumers will see just, I don't know, consume.io, let's say, domain, and they will have no idea what is going on behind this domain, but you will have the logic. It can be, again, just geo-split, or it can be much more sophisticated thing, even based on, I don't know, user email, let's say, because you are splitting the users based on their subscription tier, right? If you are doing SaaS, for example. So it's not really IoT anymore. And you can do whatever you want to redirect people to the given deployments, right? But how we can get even more with this kind of setup? We talked about some examples, but how can we get even more from this thing, right? We have let's assume we have four deployment sets, because it's enough for our company now. We don't have more money to spin out more. Yeah. Imagine your one deployment set burned. We all know likely the story of one data center in Poland, I think, in France, which burned, yeah, quite like a year ago or so. It happens. You can quickly, if assuming that your data is somehow geo-distributed, right? Because if you had all the data only here, you are screwed, yeah? But if assuming it's IoT, or you have the replicas in other regions or in other places, you can transfer the data and move the users which were connected here to another deployment set, and consumers will not really be affected, or the effect will be really limited, because they will be redirected, and for time being of this disaster, they will use another deployment, right? This is one thing which we can do with this setup, right? Another thing, with this kind of complex, let's say, deployments, yeah, and it's not really an IoT, and I will encourage you to keep thinking about this stuff, not about IoT, not about analytics, but really it can be anything. it's really hard to test big changes, right? I mean, like you are maybe introducing new microservice, you are introducing big infrastructure changes, and you are not super comfortable with releasing that to all environments and to the production environments, to the all customers at once. Yeah, you won't be able to easily do the A/B tests or this kind of stuff. Or use feature flags, right? Feature flags are awesome, but they will not work with the complex deployment of multiple microservices, infrastructure like queues and event streams, etc., because it's not enough tooling for that. Yeah, with this kind of stuff, you can do, for example, canary deployments for small subset of users who maybe won't be aware they are on canary deployment, but they will be using that, and you can move them dynamically if you switch them to this deployment, and you're monitoring because we are measuring, everything, as we agreed before, shows that something is wrong. You switch them back. That's it. They are working. They have usable system, and everything is good. And then imagine you have some beta testing, environment. They are users who want to be beta testers. As for example, I like to live on the edge, and I always on the beta release stream of the system, right? I like the risk. So they want to be on the beta system, and you can easily, like, you don't have to really be worried as much because they are aware they can run into the issues, right? Because they are beta testers, and they enrolled, so they are okay to be in trouble, right? And imagine you are running SaaS, for example, like big platform for logistics. That's where I was, and the customer, the really big customer, comes to you and they say, we will use your software, but we will not accept storing our data together with the other tenants, right? And the system is not simple enough to allow maybe just to use another database, right? Because it's complex stuff, right? You can spin up the dedicated deployment, which they will pay for, and they will use dedicated stuff while we are not affecting any other customers, right? So that's another example of the law-related stuff, as I gave the example with Indian regulations, right? So that's a thing which I was trying to mention all the time, to think outside of the box about these recipes, these solutions. Metrics are obviously universal, but a lot of this stuff can be applied in different ways in really different projects. And you don't have to really even use the whole thing, right? Maybe your system just use some kind of partitioning, right? Because your application isn't complex enough to introduce another level of complexity, but partitioning maybe can help, right? Because maybe you have again premium customer, which really doesn't need to use the whole deployment, dedicated deployment, but it would be good to like get their processing a bit faster, and that you will just partition the premium customers' data to like less loaded part of the system, right? And the lower tier customers will use the shared infrastructure or the shared part of the system, so they will maybe get a bit lower quality of the service, but they are paying less, so they are okay with that, right? So maybe you have the issue on the consuming side, right? Maybe you are pushing the data to your consumers through REST API, and they cannot handle your data because you are much faster than them, right? Because your software is so amazing and your delivery speed is so fast, so you are killing them with the data, right? Maybe you just have to introduce the queue between your system and their system, so you are not affected by that. Because if you think that you have the consumers and you are pushing the data like synchronously by REST calls, you start getting back pressure from their system, which will start killing your system, right? And you don't want to do that, so it will be like trafo in electric system where you are splitting two sides, so if something happens on the right side, it's not affecting the other side, right? And because it's separated physically, really, this won't be physical separation, but it will be a logical separation, right? And maybe you just need to redirect people between the streams or between the APIs, because for your very specific reason, right? So that can be also just the producer slash, make it not producer to make it generic, it's input router, right? So the producer or the input router can be only the solution you may need for your system. And I'm running out of time already. So yeah, do you have any questions? Okay, so thank you so much for your time, and yeah, feel free to. Thank you. Yeah, so feel free to give a like and subscribe to our podcast. This QR code goes to Spotify if you use, but we are on the other platforms, so you can then just search for Artistry of Code, or feel free to reach me by email or LinkedIn.